Lesson, we will discuss another type of differential equation. So previously, in our previous example or previous lesson, we discussed that if the given differential equation is a variable separable, meaning to say we can combine the x with the dx and the y with the dy. But there are some cases that a given differential equation, we cannot separate the x from dy or the y from dx. So let us discuss another type of equation wherein it is another example or another type of differential equation of first order and first degree, and it is a homogeneous equation. So what do you mean by homogeneous equation? A given differential equation is said to be homogeneous when the m and n are homogeneous function of the same degree in x and y. So meaning to say, the coefficient of dx, which is the m, and the coefficient of dy, which is considered as n, have the same power or exponents in x and y. So we have some examples here, like in this case, this is a function of degree of 2 because they have the same exponent or power. And we have it here that a given differential equation is homogeneous equation if the m over n is a homogeneous function of degree 0 in x and y. So what will be our solution? Just simply change the dependent variable by the substitution. This is our substitution. Y is equal to Vx. So meaning to say we cannot separate the x from dy and y from dx. So it's not variable separable. So let us discuss the first example here. Y squared minus xy dx plus x squared dy equal to 0. So when we factor the y here, so there's still remaining y. So we cannot separate the y. Then we cannot choose the separation of variable method here. So let us check if it is a homogeneous. The exponent or power of y here is square, and then we can add this, or we can multiply the power. So this is understood, this is also square. And then the coefficient of dy here is also square. So meaning to say this equation is homogeneous equation. So our solution is that we have the substitution for the dependent variable y as Vx. And then we have to replace the dy. So just look for the dy here. And then this is by means of product derivative. So we have v dx plus x dv. And then just simply substitute on the given equation. If y is Vx, so therefore this is v squared x squared. And then y here is equal to Vx. So we can multiply the x by x, so we have x squared v. And we have plus x squared here, and then we can replace the dy by v dx plus x dv there. And then obviously, when we distribute now, this is v squared x squared dx, and then we have x squared v dx. And then on the other term, we have x squared v dx, and then we have x squared x, so this is x cubed dv. Then we can combine the v squared x squared minus x squared v because they are all dx, and then x squared v dx. So here we can reduce the x squared v dx, and remaining we have v squared x squared dx here, and then x cubed dv. Then obviously this is now separable. So meaning to say we can now combine the x with the dx and the v with the dv. So we have to divide both. We have to divide the v squared here and the x cube here. So it becomes like this: x squared dx over x cube, and then we have dv over v squared equal to 0. So we can simplify it as dx over x, and then this is also dv over v squared. This is now integrable. Dx over x is leading to ln, and then this is by power integral. So we can express as raised to negative 2 as for the exponent. So this is now ln of x. This is by means of power integral, so plus 1, so negative 1 over negative 1, so 1 over v equal to c. Then all we have to do is just substitute again what is the value of v. Now since we let that y is equal to vx, then we can look for the v as y over x. So ln of x minus, this is 1 over, the v is y over x, and just simplify. Multiply the numerator by reciprocal of denominator. So this is x over y and equal to c. Or you can also transpose the x over y on the right side. So we have ln of x equal to x over y plus c. So this is now our solution or general solution for that. Now, if you want to simplify this, we can also express this as multiplied by y. So we have y ln of x, and this is equal to x plus cy. And then transpose the cy there, becomes negative cy, and this is equal to x. Then we can factor out the y here. So factor out the y, we have to multiply by the quantity ln of x minus c. Therefore, we have the value of y is equal to x over ln of x minus c. So either will be your general solution, it doesn't matter.